Welcome to Module 2. This module is an introduction to the ACI solution. We will talk about its uses and do some exploring in our environment to get comfortable with ACI and have the knowledge needed to be successful in developing an application. Software-defined networking was born to solve complexities of spanning tree, oversubscribing, and other issues. The Cisco ACI solution provides a faster means of alleviating these complexities. IT operations traditionally divide the span of administration by technology and function. The result tends to be a highly segmented support structure in which technologies, such as network storage and computing technologies, and individual functions, such as applications, information security, and network functions, are controlled by separate teams. The lack of cohesion between silos is reinforced by reporting structures. Another contributing factor is that these silos were created in the first place because the technology for which each silo is responsible serves only the purpose of that silo. This limitation also negatively affects IT's capability to meet the technology needs of the different lines of business. In fact, many lines of business are now circumventing corporate IT, instead interacting directly with external technology and cloud providers. This approach not only introduces a number of security concerns, but it also can result in wasteful spending due to the consumption of redundant services across different teams who may require faster time to market than what IT can currently deliver. ACI serves to operationally simplify the underlying technology components, creating an environment in which traditional silos must work together. Whereas some competitive solutions address complexity by ignoring the foundational infrastructure, ACI provides a means of unifying the infrastructure, instilling abstraction throughout. Centralized management principles are a critical attribute of a unified infrastructure built using open standards. ACI thus makes activities such as capacity planning, forecasting, monetary showback and chargeback, application-specific service level management, and other operation-leading practices that are essential to IT transformation much easier to accomplish. There is a disconnect between the languages used by networking teams and application teams. Networking teams talk about things in terms of switching, routing, VLANs, and QoS, while application teams use tiers of applications, security compliance, and tenants. Within ACI, we now have the ability to translate the intent and requirements of an application onto the infrastructure, which provides consistency across the network. Policy is broken down into simpler model. What groups of things need to talk to other groups of things? Application network profiles provide a logical end-to-end implementation of the intended policy and are reusable for other similar applications. This is accomplished by abstracting the policy away from networking policy like VLANs, while still doing the tagging internally in the network. But the policy model does not care about those details. Let's begin to explore ACI. Your network administration team can provide you with the URL to access your specific ACI environment. Here, we are simply visiting the IP address of one of our APIC controllers in Chrome. You will be prompted to log in. The first screen presented will be this, the ACI dashboard. Let's take a look from within the GUI at our environment and talk a little about the ACI solution. Here, from the Fabric tab, we can see our topology. We have one APIC controller, one spine, and two leaves. The leaves represented here are where anything in our data center is physically connected to the network, such as servers, firewalls, and load balancers. The APIC controller is simply a server which acts as the interface by which we define all policy. The APIC will then take our policy and push it out to all the leaf and spines in the network. This is accomplished using REST API calls. Let's now take a look at what is happening here in the GUI under the hood. If we open up the API inspector, we can see our interaction with the APIC. Anything we do within the GUI here is performed via the REST API to the controller. This is the same means by which we will implement the functionality of our application. Anywhere we browse within the GUI here, we can see the exact URL that was called and the responses provided by the APIC in the API inspector. Also in the Fabric tab here is where the Fabric access policies are defined. These are the infrastructure policy that our network administrators configure that are needed to attach things like servers to the leafs. If we browse to the Tenant tab here, we can see all of the tenant-based application policies defined. This is where policy is defined to group things in the network and define what these groups of things are allowed to communicate with. If we take a look into our demo tenant, we can browse around some of the common policies. These will also be relevant in the specific application we develop throughout this course. Here we can see the application profiles in our demo tenant. We have one profile, Coke, and one called Pepsi. If we open up Coke, we can see the policies inside that it contains. Within every application profile, we will find EPGs. These EPGs are endpoint groups. Simply, this is where we are logically grouping servers. If we have web servers for our Coke application, they go in the Coke Web EPG. Application servers for Coke would go in the App EPG, and the database servers would go in the DB EPG. Each EPG we have will be associated to some bridge domain, which contains things like subnets for default gateways of the servers. Here in the networking section, we can find the bridge domain policies. Similarly, the bridge domains are each associated to some VRF space. Here we can see the VRF this bridge domain is associated with. Also in the networking section here, we can find the configured VRFs. In ACI, the means by which we allow our servers contained in each endpoint group to talk to each other or somewhere else like the Internet is done using contracts. A brief example of this can be seen if we look at the topology of the Coke application profile. Here we can see the relationship between the Web EPG and the Internet. The Web EPG is also allowed to talk to the Application EPG. The Application EPG is allowed to talk to the Web EPG and Database EPGs. The Database EPG will only communicate with the Application EPG. Now that we have a very high-level overview of ACI, let's take a look at some of this policy. Let's say we want to look at the JSON of one of our application profiles to see all the properties within it. This would be a possible example of gathering information related to the development of an application. If we right-click on our Coke application profile, we can select Save As. We will choose only Configuration, Subtree, and to give us everything in JSON format. The subtree item here is so we can get all of the children of the Coke application profile. We want to see all the EPGs and their configuration as well. Now we can open this in Visual Studio Code and gather information. If we now format the document here, we can browse through and see all of our EPGs and their associated policies, like the bridge domains associated to each EPG and contracts. Here at the top, we see the Coke app. Its children are, for example, the DB EPG and the children of that EPG. We can see the associated BD and contracts. Now let's talk about an ACI application. As we saw earlier, we can go to each application profile and view its associated contracts in the topology view. This is something your network engineers might be doing. Let's say they want some more granular information based on usage and all of the topology for their entire tenant. Well, by default, they don't have the view they would like. The solution is to get with you, the application developer, and relay this use case. They will present you with what they would like. Then, upon gathering all the required API calls needed, we can develop an application that can be installed so that the network team can have this added functionality. We have as an example the ACI Contract Viewer application installed here. This is an example of a final product of a use case that we can take a look at now. With this application example, we can see contract relationships represented for all our application profiles, like the network team wanted, now in the context of each tenant. Let's take a look at how we installed the application to our environment. Here we can see the ACI applications. From here, you or the network team can download after clicking the link to get to the ACI application marketplace, or upload applications to install to ACI. As an example, let's go ahead and remove the Contract Viewer application from the environment so we can go through the install process again. The option to download an application from the marketplace is the box with the down arrow here. This opens a new tab to aciappcenter.cisco.com. From here, we can browse through existing applications, and if we log in, we can download any of these published ACI applications. Since we already have this downloaded, let's take a look in our Downloads folder for the Contract Viewer application install file. To install this application, we go to our APIC, and in the same app view here, we click the box with the up arrow, and we will select our Contract View application. Once the upload is completed, you will see the application installing. Be patient, and once the install is completed, we can now enable the application. This application is now installed and available to the network team within their tenants. This concludes Module 2. In the next module, we will look into two different types of ACI applications.